Chapter 4.5 also goes together with Chapter 4.7. This is going to cover, again, two sections. 4.5 is about completing the square, and that is the introduction of the process. There is actually a way of solving by completing the square, but in our opinion, in terms of the math teachers of the district, we don't really need to push solving by completing the square because there's always other options. We'll probably go over it in class at some point just to show you and give you the option. But again, the process itself is important. The second section is going to actually represent it, which you'll in a way that you'll use it more. And again, we'll close out the lesson and I'll show you what I mean by that. But completing a square, the process itself represents, it's a very simple, straightforward process, but again, it just represents creating a perfect square trinomial. The first thing you want to do is isolate the x terms. The second thing you want to do is cut that b value, which is the one that has an x on it, in half, and then square the value we just created. Again, those three steps, nothing difficult about any one of those, so it's really not a bad situation to be into. So just go ahead and look at some examples because again, there's really no high-tech way to explain it. So what we do here, this is already isolated. You just want to complete the square. You might see a question that says complete the square to find the value of c to make it a perfect square, and here's what you do. You're going to need a second line because we are actually going to create a perfect square. We're going to create x plus, because of that, and then cut b in half. That's what goes here, and then that 5 squared becomes 25 because x plus 5 squared is this part right here. So again, we just pretty much took this part, cut 10 in half, which is the number you're going to get here, 5 squared, 25. And again, just to show you, if you were to take x plus 5 times x plus 5, you do end up with x squared plus 5x plus 5x plus 25. 5 and 5 make your 10. Sorry about the sloppy numbers. But again, 5x and 5x make your 10x, your 25 is there. So again, this is what we're going to create, but that's the number that we're going to actually move or put into that blank. X squared minus 6x plus blank. Again, what we're going to do is complete the square on a different line. Minus because this b value is negative. Half of 6 is 3. Square that because again, that's how we complete the square, and anything squared is going to be positive, which means that 3 squared turns into 9. That is the number. So again, negative 3 plus negative 3 is negative 6. Negative 3 times negative 3 is a positive 9, and there you are. And then c, well, this happens anytime you have a odd number, but again, what you will do here is just use fractions. So whenever you cut a number in half, you simply put it over 2, and when you square that number, you will put and actually square both, so it'll be 25 over 4. So again, 5 times 5, 25. 5 times, 2 times 2, 4. That would be where we are. Let me make sure just to, didn't really work these out, but I need to make sure. 5 halves squared, math, enter, yep, 25 over 4. So just want to make sure I didn't make any silly mistakes on the way because I really didn't work this out in my head yet, and I just made these up. Let's consider the difficult part. What we just did in all these blanks is create a value out of nowhere. So again, this was here, and these blanks represent values that we just created. And that works whenever there's no equal sign, but whenever you have an equation, you have to actually have some balance. So whenever we create a value, we have two ways of actually offsetting that, and that is where 4.5 and 4.7 split. 4.5 does one thing, 4.7 does something else. We're not going to use, again, the 4.5 method. I might do it a little bit in class, but again, I'm not really worried about the method used in 4.5. But the first thing 4.5 does is they add the same value to the opposite side. So in other words, if this was a scale and it was already balanced, and we added, let's say, 10 to this side, that just got heavier by 10, and so what we can do to offset it is to add 10 to that side, and then it's balanced again. So whatever was there was already balanced because that's why it's called an equation. And so if we add 10 over there, then we also add 10 over here, and that would be one way. 4.7 on the other hand does the other one, which is you subtract the value from the same side. So again, if I add 10 to this side, I just made this heavier by 10. But again, in most situations, it's like when we do our vertex form, you cannot touch the other side, so the way you offset adding 10 is by also subtracting 10 from the same side, because positive 10, negative 10 cancel each other out, and the equation is still balanced. Alright. So getting into what we're doing now, again, 4.7 is in order to convert standard form to vertex form, we will have to use the second method because, again, every vertex form, every standard form has a y equals side, and you cannot touch it. That is the main side of what you need for any kind of graphs for quadratics. So let's go ahead and see what happens here and write the equation in vertex form using the 3 steps that we said, which is isolate the x terms, cut the b in half, and then square it to create your new value. So what we have here is y equals, and isolate your x terms, so x squared minus 6x. And then you're going to add a blank here because we know we're going to put a value here just like we had on our examples. The 3 stays on the outside. And if you added a blank here, then you are going to have to subtract that same amount out here. So this is kind of like your setup. You don't really need the blanks, but it helps you to kind of know what's going on. Here we go here with y equals, and then we're going to go ahead and complete the square here. That'll be x minus 3 squared. 3 is going to make a 9. Adding 9 here needs to be offset by subtracting 9 here. Again, this is on the same side. I just created a 9. I have to offset it by taking the 9 away. Now I simplify these two parts. Positive 3, negative 9 makes negative 6. The vertex is 3, negative 6. Because if you remember from parent functions, that number switches, that number stays the same. Alright, so again, not tough, just make sure you are aware of what just happened there. Okay. Second example. Now this is where things get tricky, and again I need to make sure I do this because since this is 6 weight, you need to be ready for difficult versions. So again, we are going to isolate the x's, but we don't want anything attached to x squared, so we're actually going to take the negative off of the x squared. The tricky part about that is if you take the negative off the x squared and this 4 is going to be in there, we must switch that 4 to be its opposite. You will then add a blank, which we know we're going to do. But here's what you need to understand also, even though negative 1 is out here. If I am adding a number here and multiplying it by a negative, we know that number is going to be positive and it's going to be made negative, which means we're actually subtracting a number here, which means we need to add the same number out here. So again, the number we create here, if we create a 6, is going to be multiplied by a negative, which makes it a negative 6, which means we have to offset it by adding a positive 6. But anyway, keep your negative. Complete the square, which means x plus 2, because that's what half of 4 is. 2 squared turns into 4. Again, this 4 is actually a negative 4, which means we want to add 4 on the outside. Negative 1 and positive 4 make a positive 3. That is the square completed. That is your vertex form with the vertex of negative 2, 3. That negative does not affect your vertex because if you remember, that is still going to be opposite of this, and that number stays the same. The thing that it tells us though is that this is a upside down parabola, which means it has a maximum instead of a minimum. But again, that was something else that affected your graph in a different way, but that does not affect your vertex. C, again, something attached to x, so we first off have to isolate it, so we're going to take the 4 off. Again, you have to keep in mind that if I'm taking 4 off of this, I'm also going to take 4 off of the other x term, which means that that'll be minus 6x plus blank. 7 stays out. Again, this is positive, that's positive, which means we need to subtract a blank out here. So when we go to complete the square, you keep your 4. It'll be x minus 3 because that's what half of 6 is. 3 squared makes 9, but here again is where you have to be careful. That is a 9 being multiplied by 4, which means this is actually a 36, which means we have to put a 36 out here. Again, anytime there's a number out there or a sign, you have to make sure you understand that sign affects the number you put on the inside, which means that this ends up being negative, I think, 29. This is your vertex form with the vertex of 3, negative 29. So again, the axis of symmetry is x equals 3. We know that this has a minimum. Your minimum would be y equals negative 29. So all that stuff can come out of this. You don't need to do a lot of work. That is the benefit of vertex form, because in standard form we have to do the negative b over 2a, plug in all the numbers, check and see what's going on. Whereas once it's in vertex form, you have your vertex, you have your axis of symmetry, you have your max or min value, And like I said, for the most part, you can even get things started by doing your plots the way that we learned before. All right. And then, of course, one tough one, just to make sure we get everything together. So again, isolating your x means we're taking off a -5, and we are left with x squared minus x, because remember this negative is going to switch that sign there. 5 divided by 5 is 1, plus blank. So again, -3 stays out, but again, here's what you have to recognize. This number is going to be positive. It's going to be multiplied by a negative, which means we're actually going to be adding a negative value. So we must make sure we add that amount out there. Now let's get to the real stuff. -5 here, that will be x minus, this is a 1, so it'll be x minus 1/2 squared. Yes, odd numbers exist, fractions exist. So 1/2, again, this is a 1, cut it in half is 1/2. When you square that, you get 1/4. When you take a fraction times a whole number, the whole number multiplies to the top. So it will be -5/4 out here. And this is where we have to do a little bit of work. You need 3 4, so that'll be -12/4, because again, 12 divided by 4 is 3. Minus 5/4, which is -17/4. Again, you can check this out in your calculator by simply doing -3 minus 5, put it in parentheses, 5/4 equals math, enter. There's your -17/4, which is what we end up with here. Your vertex is 1/2, comma, -17/4. The last two questions on your homework do look like this, so you're gonna have to maybe think a little bit. It's not well, I guess it's not an easy question either, but you'll be fine. Just make sure again that you ask for help when you need it. I'm pretty sure if you come up to me, I can probably get you under control as long as you've got the concept down, and by the time you get to the end of the section, you should have most of it at least understood. Alright. So the process is extremely important for graphing higher level functions. You will get into what they call conic sections, and that means there's a whole lot of different graphs that you have to know. For example, the graph of a circle. Now that you know how to complete the square, you now know how to actually graph a circle. What you would do is isolate your x's, isolate your y's, and because it's on the opposite side, we are actually going to do the same thing here. So we're not going to change the left side. This is where 4.5 does. If I added it over here, I'm going to add another blank over here to offset this one, and I'm going to add another blank over here to offset this one. You then will complete the square. This is of course x plus 3, because half of 6 is 3. This is going to become a 9, which means that I need to put a 9 over there. Plus, the other one is y minus 5, as we know, because half of 10 is 5. That's 25. This is 25. And then you put all that together. 18 and 25, I believe, make 43. And what you would do to graph this, this would be called, because it's a circle, your center. Use the opposite of this number. Use the opposite of that number. This actually would lead to your radius, which of course you need to unsquare it or square root to find your radius. But again, this is information you will be using with a higher level of graph, and again, you now know at least enough to kind of do some stuff like that, which is going to help you out. So again, keeping all that in mind, that is the main thing you need to know, is again, this process of completing a square, which is why we want you to see it, actually has a lot of applications when it comes to graphing. So make sure that you are aware of how all this stuff works. Other than that, Math Excel is waiting for you. Good luck.